Hi students, welcome to Wisdom Academy and welcome to class 11th. This is my first video where I am going to start the 11th class. I will not start with the first chapter, that is physical world. I will just talk about what is physics today with you, and I will just talk about some basic fundamentals of physics today. So in this video, more than learning about 11th physics, I want you to learn about what is physics. I want you to learn about what are the branches of physics. I want you to learn why are we studying this physics. So this physics, if you see, as a book meaning of physics, you will find like it is a branch of science which deals with so and so and so, and it relates something with the universe and finding the behavior of the universe and all those stuffs. Definitely these things, this bookish definition will make you like confused or will make you least bothered about what is physics. But actually, if you see the beauty of physics, you will fall in love with it. So the physics is a branch where you get the answers of all your questions. Like why this fan is running? Answer is there in physics. Why this light is glowing? Answer is there in physics. Why this camera is working? Answer is there in physics. Why am I able to write on the board? Answer is there in physics. How are we doing this? How can we do this? Answer is in physics. We can predict the future by using the physics. I'll take one small example to tell. I'll connect all these things, connecting why, connecting how, and connecting future of things. So, for example, I talk about a person riding a horse, and when he is riding on a horse, the horse is able to move in the forward direction. The first question which comes in the mind is, why is the horse moving in the front direction when the person sitting on the horse is pulling it in the backward direction? Have you seen how they ride the horse? When they ride the horse, they ride the horse like this. When I am pushing the neck of the horse in reverse direction, how come the horse walk in the front direction? That why, the answer is there in physics. How come with the help of the legs of the horse, it is able to take that much load? Have you seen how much small the legs are of the horse? How much thin size the legs are? Like it is comparable with human leg. With that 4 legs, how the horse is able to walk so and so many kilometers, run for so many kilometers without even falling tired like how we fell? That answer is there in physics. With the idea of how the horse runs on the road, we can even design the machineries, we can design the vehicles which can run in a very fast way. But that is predicting future. Not only this, we studied about why does the fish swim inside the river or ocean. How does the fish swim inside the river or ocean? And by that knowledge about streamline flow and how the fish swims, we designed a lot of cars today. We designed helicopters, we designed aeroplanes, we designed a lot of things which are flying, because that streamlining concept was a revolution in the era of vehicles. So physics is not only about learning motion, light, mirrors, electromagnetic waves, electricity, current, all these things. Physics is about finding the answer of how, why, and with these answers trying to predict the future and making it a better place for living. Not only this, like if you see the whole universe study, when you see a star, why are you able to see the star? Why is star visible to you? Why star twinkles in the sky? And how much far is star from you? All these answers can be, like, you can get the answers if you are really interested in physics. So let us try to learn physics in the most interesting way, rather than making it just a book for you which will make you feel a lot boring. So my aim will be to always keep you interested and try to tell you the typical things which are often answered in the class. So my aim will be that, and let me see how much you get interested. So first, I would like to tell you what are the different branches of physics. So to divide the branches, I have taken the help of Wikipedia. and I am dividing the branches of physics into 4 parts. That is, first I am writing here classical mechanics, then I am writing here relativistic mechanics, and then comes quantum mechanics, and then we have quantum field theory. Now these 4 branches of physics, how do I classify? I classify based upon 2 ranges. One range is the velocity and one range is the size. So if I will write 4 quantities here. This is less than 3 into 10 to the power 8 meter per second. This is more than or equal to 3 into 10 to the power 8 meter per second. This is less than 10 to the power minus 9 meter. This is greater than 10 to the power minus 9 meter, and this is less than 10 to the power minus 9 meter. So if you see this chart, you will get an understanding that all the quantities or all the objects or particles which are having a speed less than the speed of light and having the size more than 10 to the power minus 9 meter comes under the study of classical mechanics. So what is classical mechanics? Classical mechanics is a part of physics where we learn about the things which are having a velocity less than the velocity of the light and having a size of more than 10 to the power minus 9 meter. So I will tell you, all your volume 1 of 11th physics will fall under classical mechanics, right from motion to the laws of motion to work, energy and power, your rotational mechanics till gravitation, whatever, even I can say that mechanical properties of solids and fluids, it comes under the category of classical mechanics. Then relativistic mechanics. This is when the size of the object can be more than 10 to the power minus 9 meter, but the velocity with which the object is moving becomes greater than or equal to speed of light. So I have recently made a video in the Factoid series where I have talked about time travel. So in time travel, our concept of mass, time and length gets a lot changed, because you would have studied till this time that mass is constant, mass never changes. But when you really start understanding relativistic mechanics, which was given by Sir Einstein, you will realize that even the mass changes, even the time changes, time gets dilated, mass gets change, your length gets contracted. Things happen which are beyond the study of classical mechanics, and those things are coming under the area of relativistic mechanics. We hardly learn about this since it is a little higher. This you learn in college life. Like hardly we learn anything about this in school. You will have basics of this, but not in detail. Then comes quantum mechanics. So in quantum mechanics, the thing is, the speed is less than the speed of light, but the size becomes less than 10 to the power minus 9 meter. So it comes under the atomic size or nuclear size. So if things becomes very small in size and it is moving with a velocity less than the velocity of light, that study of physics comes under the category of quantum mechanics. Now when I say quantum mechanics, it deals with atoms, molecules, it deals with nuclei and all these things. This thing is there in 12th physics, where you will learn about atoms, you will learn about nuclei, you will learn about semiconductors, you will learn about theory of lights. All these things I will classify under the category of quantum mechanics. And then the fourth and the last one is quantum field theory, a recent theory or a recent branch of physics which is now most discovered, or I should say most researched branch. So every scientist from various parts of the country are doing a lot of research under quantum field theory, where they are still discovering new particles, they are still trying to synthesize energy from the atom. And if we are able to do so, then we will have lots and lots of problem of power solved. So quantum field theory will be the branch of physics where the particle size is in the range of 10 to the power minus 9 meter or lesser than that, and the speed becomes more than the speed of light. So for this thing, those who have seen the movie, Marvel movie Ant-Man, they would have heard something about quantum field theory there, where the Ant-Man is going to very small size And then if you would have seen one person, I think that scientist who discovered pin particle, he becomes very small and his wife goes to quantum field. So I mean, there they have talked about quantum field. Definitely it is a fiction, but this is the area which is in a lot of research in today's world, because that is the only place where we can solve all our problem of energy, which will not be solved by burning coal or burning some wood or using some wind energy. Yeah, definitely it is conventional source of energy, but we must read, we must synthesize things present in quantum field to really get a lot of stuff. So this is about the different branches of physics. Now let us see about the fundamental forces of nature. So basically in nature we have four fundamental forces. If I name them, they are gravitational force, very commonly used force. Then we have weak nuclear force. Then we have electrostatic force. And then we have strong nuclear force. I have written about all these forces in the increasing order of their magnitude. So I want to say that this is the weakest force and this is the strongest force. So gravitational force is one of the weakest force in nature. It is one of the weakest force. You will learn about why it is weakest force and how much weak it is, you will learn. Shall I give you one small example how weak it is? Suppose, first of all, you would have learned about gravitational force in your 9th standard itself, and there you would have learned the formula of gravitational force as F is equal to G m1 m2 by r square. And there they would have told you that every two bodies in the universe attracts each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of distance between them. And then this doubt would have definitely come in your mind. Some of you would have asked your teacher, and I don't know what reply you would have got, and most of you would have not even asked your teacher. But this doubt would have come to most of your minds. Doubt would be like, if this force is really true, then why am I not getting attracted towards other student? Like, if two things are attracting each other, why don't I feel a force towards that person? Why don't I feel a force towards this board? Why don't I feel a force towards the wall? If two things are attracting, then they should come closer. Why does not it happen? That doubt, if you have cleared, very good. If not, let us clear it today. So take two examples. Like, suppose I am taking two masses. I am taking myself, I am taking you. So your mass I am assuming to be 50 kg, my mass I am assuming to be 80 kg, and then let us see what is the force between me and you. So I am assuming m1 to be 50 kg, I am assuming m2 to be 80 kg, and I am trying to find distance. And let me assume that you are very close to me in the range of 1 meter. Though social distance has to be maintained, but let us see 1 meter. So F is equal to G is 6.67 10 to the power minus 11 into 50 into 80 by 1 square. Am I right? When I solve this, I will solve approximate now. So 8 5 is a 40, and it will become 40 and 2 more zeros are there into 6.6 10 to the power minus 11. So when I multiply these two things, so it becomes 4 approximately I am writing 25,000 and 10 to the power minus 11 Newton. Can you see 10 to the power minus 11 means if I start putting 0, it will be 1, 2, 3, 4, 5, 5 and 6 more. So 0, 0, 0, 0, 0, 0, 2, 5, 0, 0, 0 Newton. This is the force that acts between you and me when you are 1 meter apart. If you are 100 meter apart, imagine how much small it will become. So this magnitude of force is that much less, that much small, that we are not able to even feel it. That is the reason gravitational force is one of the weakest force in the nature. Gravitational force is a long range force. It's a long range force. What do you mean by long range force? it acts even in infinite distances. You see sun and the earth, how far they are, but there is a gravitational force between them, because it is a long range force. It is present between two bodies which is very far apart from each other. See, our galaxy itself is under a gravitational force of the galactic center. So, gravitational force is a very long range force. Let us talk about the second force, nuclear force. This nuclear force has always puzzled me. When I was in my 9th standard and my teacher taught me that inside the atom there are particles. We have protons, we have neutrons, we have electrons, and the teacher told me that the protons are lying inside the nucleus. And all the protons are together. Around the nucleus, we have electrons revolving. I got a strange doubt, and my doubt was, all the protons are present inside the nucleus, why are they not repelling each other? If everything is inside the nucleus, they must repel each other. If they repel each other, then how come they are binded? Why don't they come out of the nucleus? This doubt was cleared only when I reached 11th. I did not dare to ask to my teacher, and I never got it cleared. When I went to 11th and read the books, only then I got this cleared. So the answer to this thing is nuclear force. There is definitely a force of repulsion, but there is also a force of attraction. You will learn about this more in 12th standard, where you will learn that all the particles of nucleus, also called as nucleons, they are under attractive force that is called as nuclear force, and this nuclear force keeps them binded. Now, sir, you told that nuclear force is very strong, then why you put it above this and why you wrote weak word here? Because nuclear force you learn in the higher standards, there are two types, and this weak nuclear force is caused by beta decay. I don't want to confuse you more. I don't want you to get stressed about physics. Don't just see this term as a word now. You learn it in the higher classes. That time it will be very simple. There are two kinds of decay, beta plus and beta minus decay. Whereas beta decay is creating this weak nuclear force, and they are short range force. They are short range force. Then comes electrostatic force. Electrostatic force is stronger than nuclear force, but weaker than strong nuclear force, definitely. And electrostatic force is the force of attraction or repulsion acting between the particles inside the atom. So, if one electron is there, one proton is there, they will be attracted by what force? By electrostatic force. One proton and proton repelled by what force? Electrostatic force. And that force is given as F is equal to K Q1 Q2 by R square. This is the formula to calculate the electrostatic force, where R is the distance between these two particles. Remember that this is again a long range force, and definitely it is stronger force. This acts between charged particles. So, if there is no charge, there will be no electrostatic force. So, neutrons, no force. Neutrons, protons, no force. Protons, neutrons, electrons, no force, because neutron is having no charge over it. But neutron, proton, and proton, all these three nucleons are under an attractive nuclear force. So, nuclear force, the strong nuclear force what I have talked, is again a short range force, but it acts on all nucleons particle I will write. So, when I say all nucleons particles, means neutron, proton, and also proton. All these three combinations, this force will be acting. Whereas this will not act on neutron itself. Now, you can understand inside the nucleus, if I have 5 protons and I have 5 neutrons, these 5 protons among themselves will be under electrostatic force, but all these 10 particles will be under nuclear force, and they become strong and hold the nucleus, and nucleus does not disintegrate. But then how the radioactive decay happens, you will learn about it in the 12th itself. Don't worry, it will come. So now we have discussed about all the fundamental forces of nature, and I said gravitational force, weak nuclear force, electrostatic force and strong nuclear force. Once again, if I revise, then gravitational force is one of the weakest force and long range force. The formula of gravitational force is given here, and I said you why it is very weak. Weak nuclear force is acting due to the beta decay. It is a very short range force. Electrostatic force is a long range force and acts between the charged particles only, and strong nuclear force is a short range force acting on all the nucleon particles. Now I will give you one homework. So today the first day, and today itself start giving homework. Yeah, because homeworks should not be taken as a burden, it should be taken as a task to be accomplished for attaining your goals. So the homework to you is, you have to compare the gravitational force and the strong nuclear force, okay, or leave this, you just compare gravitational force and electrostatic force between two particles. You have to take one proton, you have to take one electron. Please note it down, one proton and one electron, and take the distance between them as 10 to the power minus 10 meter. This is the R value. This is the value of charge on one proton, one electron. These things you learned in basic class. That's why I am giving this homework to you. And if someone is wondering what is the mass of the proton, you can see in the books, but I will write it here. Mass of the proton is 1.6 into 10 power minus 27 kg, and mass of electron is 9.1 10 power minus 31 kg. This is the mass of proton and mass of electron, and I want you to find both the force, compare and tell me in the next class what is their ratios. So with this I am ending today's class. I hope that you have found some interest in physics. For more interest, keep on watching my videos, like it, share with your friends and subscribe my channel. Thank you.